We are observing an unstable flashing pattern on the indoor unit's display. It isn't a standard error code. It looks more like an inconsistent flicker. At the customer's home, you saw that the display was flashing. Now, I am connecting it to electricity in the workshop, and as soon as I powered it on in the workshop, there we go. The display is working now, and you can see it properly started showing a 16-degree temperature, and the fan motor has also started. Now once I will turn it on and off with the remote, it has properly turned off, and its red light is on. Now I am turning it on again. Since the outdoor unit is not installed with it, it should give an E6 error. The E6 error has appeared, and because it cannot communicate with the outdoor unit, that is why the E6 error is showing here. Now I will shake this PCB a little. Maybe there is some loose connection, because I physically checked it, but there's nothing like that in it. Because the customer told me to check the PCB, maybe there is some loose connection in it. That is why this problem is happening. So I said I will take it to the workshop and check whether there is really a loose connection in it or not, but I cannot see any loose connection in it. Now what kind of issue is there in this PCB because of which this problem is happening? So here are some things that I have noted, and I will share them with you. So look, right now when I checked it in the workshop, it is completely fine here. This means that even if we try to find the fault here, we will not find it because everything is working properly and correctly in its place. Whereas at the customer site, the issue is what I showed you. So either we should take all the equipment there and properly test it there, then we will find out. And if I have to repair it in the workshop and take it back, then there are some things that I will have to check here. The very first thing that needs to be analyzed in this is that its outdoor PCB came to me for repairing. But look at this indoor PCB here. It's switching IC, and along with it, this capacitor installed in it. Someone else has changed these in another workshop. Look at this one, which is 22 microfarad and 450 volts. And look at this IC installed in it. It has a TNY274PN installed in it, whereas normally a 278PN is installed here. If we look at this 74 one, I will remove it. Look at this, someone has installed a TNY274PN here, whereas in this PCB the capacitor installed here is approximately 47 microfarad and 450 volts. I will have to check it, but still I feel that the microfarad value installed here is lower. Apart from this IC here is normally a TNY278PN installed here, whereas if we look at the power rating of this 74, it is 6 watts, meaning its power rating is very weak. If we install an IC with this power rating in a place where there are fluctuations, where there is noise or some kind of issue in the electricity, then it will not work there because it does not have enough power. So because of this, the system can create issues in this way. If instead of this, we install a 278 whose power rating is 16 watts and its peak goes up to 28 watts, now the 74's peak goes only up to 11 watts, then because of this, this problem can happen. So this could be one possible reason for the issue happening in it. And secondly, if this capacitor is smaller, then what will happen is that if the voltage here is not stable, then this capacitor will not properly perform the filtering function. When the filtering does not work properly, then obviously this component will also not work correctly, and in this way, the feedback generated in this system will not work properly. When the feedback does not work properly, then this system will keep turning on and off. So this can be a normal idea for us, and this problem could happen because of these reasons. So I will work on these things and check it, because these are the two things here. And after this, these two TL431s are very important for the reference voltage, and this optocoupler, because of which the feedback is being received by this IC. So these 3 or 4 things are the ones that I need to change here. Now, I have this IC available here, the TNY279PN. It has an even higher rating than the previous one. While it typically runs at 18 watts, the power consumption can spike to 32 watts under full load. So its endurance is quite high. So now I'm going to install it here. And in this one, we just have to place it and press it in. It looks like someone has already worked on it before. I think this base, so we're going to remove it. I've taken the base out, and now we'll install the IC directly. This way, there won't be any fluctuation or loose connection issue. So this could also have been one of the problems. And And this capacitor also looks suspicious to me. It seems like someone has worked on it before and installed an old one here. If it is old, then its ESR may have increased, and because of the higher internal resistance, it won't work properly. And if it doesn't work properly, then the whole system ahead won't operate correctly either. Right now, the voltage we have is very stable, which is why it's still working fine. But if any stress comes on it, this capacitor may stop functioning properly. So now we're going to install this capacitor here. It's a 47 microfarad 400 volt capacitor. I'll install it here now. And since the microfarad value is a bit higher, if there's any electrical disturbance or ripple in the supply, this capacitor will filter it more effectively. Now, since there was a blast here, I'm also going to remove the bridge rectifier, because this can become a headache later as well. I'll remove it first and then change it. After that, we'll also replace these three parts: the feedback optocoupler and the shunt reference IC TL431. In the same way, this capacitor here is sometimes connected with the IC setup and is part of the feedback section. If the voltage here drops, it can also create problems, so we'll replace this one too. This capacitor is used for voltage stabilization in the feedback circuit, so I'm removing it as well. It's a 10 microfarad 25 volt capacitor, and in the same way, I'll also remove the feedback optocoupler. This is the PC817 optocoupler. So, this here is the TL431 reference IC. Now I'll place all these parts here and solder them properly. And we have to be very careful about the positive and negative polarity, because if the positive and negative connections are reversed, it can blast. Now let's test it once in the workshop and see how it performs. It is powered on completely now. Now I'll turn it on with the remote. Okay, good. Let's wait for the fan motor. Yes, it has started. That means everything here is working properly now. And the system is stable. And now the fan motor has also turned off normally.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.